I'm Chris Favre. I'm the content manager for plant engineering, and welcome to this installment of the Maintaining Your Plant Floor Edge series. Maintenance is a crucial aspect of manufacturing and helps workers remain safe and productive and keeps machinery operational and lasting longer than ever. Maintenance, though, is so much more than that. It's a philosophy and it's a discipline, and how it is applied differs from company to company and person to person. So how do you keep maintenance at a high level, and what does your company practice to stay consistent in their quality? This series examines how subject matter experts and their companies work to keep maintenance at the highest possible level. Today's subject matter expert is Mark Ruffin. He's the Vice President of Sales for Teadit North America. He will discuss the repacking of valves used in the industrial sector and how the importance of monitoring the packing to prevent leakage and how to mitigate the risk of future leaks from a maintenance perspective is so important. Welcome, Mark. Thanks for joining me today.
Oh, thank you. The pleasure's all mine. Really appreciate being a part of this. I'm the Vice President of Teadit North America. I started in the industry as a reliability engineer with BP. After that, I joined Chevron as the subject matter expert for bolted flange joints. And about 2 years ago, I had the exciting opportunity of joining Teadit as the technical director. Earlier this year, they promoted me to Vice President of Sales and Engineering, where I've had a steep learning curve, but I'm enjoying every minute of it.
So you got a pretty rich background in a lot of industries where maintenance is a crucial aspect for sure. And given your experience, what do you see as the current trend in maintenance for industrial and manufacturing facilities and companies?
Yeah, one of the current trends that I see is a desire for an increase in time between turnaround cycles. So previously, a very common turnaround cycle was 5 years. I see a lot of work of trying to extend that out to a 6-year cycle. So that's a 20% increase between maintenance opportunities. This can lead to unplanned shutdowns, which can be hard on different types of equipment, right? So the longer equipment runs, the more possible wear, the more potential for unplanned shutdowns, which again can be hard on equipment. For example, for sealing technologies, the thermal changes that take place during an unplanned shutdown is hard and affects the buffer against leakage for both gaskets and packing.
Mhm. Yeah, and companies are trying to stretch their products out as much as they can, but as you say, downtime can have such a negative effect if they push too hard or too fast. And do you see any future trends that engineers and plant managers and designers should expect as far as predictive or preventive maintenance? Like the next couple of years, what trends are you seeing? Should they expect?
Well, so with respect to sealing, I think one thing that they can do as a preventative measure is to go back and retighten the joint. So sealing applications will self-loosen all on their own. And the term for that is called relaxation. So the joints want to relax all on their own. And as they relax, they get closer and closer to being being in a scenario where a leak will occur. So going back and retightening, whether that be on some sort of regular interval or just doing it once right after assembly, will significantly increase the length of time in which that joint can operate without having a leak.
Mhm. And you're talking about joints and valves, and they play a key role in maintenance activities. You mentioned relaxation, as these valves and joints, so kind of loosen on their own. Are there other potential issues associated with these valves that engineers need to be aware of?
Really, it has to do mostly with the relaxation. So that's the issue with longer and longer run cycles is the self-loosening effect that they need to be concerned with.
Hmm. And are there technologies like sensors that can help, companies kind of get out in front of this if possible, or is it something that has to be very much, maintenance engineer has to be right there to see it?
No, so in fact, it's actually very hard to see. So the more sensors that you can use, the more likely you will be to be able to be aware that the self-loosening is taking place. Unfortunately, some of that technology can be considered a bit pricey, and so
Mhm.
it's hard to apply that technology to all of the different type flanges and bolted flange joints. And when I say bolted flange joints, that definitely includes the valve packing portion of it.
Mhm.
So there is technology that can sense from the stud how tight it is, and therefore how tight the sealing component, whether that be gaskets or the packing and valves, how tight that is. But one thing that they can do, I go back to the retightening. So that's just going to be a huge helpful thing to implement early on in the life. You can even do it, shortly after starting up, if safe to do. So around 3 days after you install the packing and it's been um, in operation, going back and regaining that initial loss of tightening out of your stud will significantly increase the life of the packing.
Mhm. And you talked about your background. You've worked in industries where harsh and dangerous environments are part and parcel of the day to day, and valves can be easily damaged in some of these environments. To prevent damage, or at least mitigate the damage, because perhaps it's inevitable. But what are some best practices engineers can take to try and in through maintenance in that way, keep them lasting as long as possible without causing issues in production or quality?
Sure. So there is a standard out there called API 622. This standard specifies a test that packing has to undergo in order to be considered certified low leak technology. Part
Hmm.
of that test is to um, look at the corrosion that the packing can have on the body of the valve or the stem of the valve. So simply referencing that test, determining what packing is best for your application, can really help with the corrosion aspects that you might be seeing in some of the applications that you just mentioned. But in order to have that certified low leak technology, the packing has to have enough structure to it to where it can withstand the amount of force that you put on it over a long time period with many cycles. And in order to accomplish that, oftentimes you introduce a metallic wire to the packing.
Hmm.
The dissimilar metals between the wire that's in the packing and the stem or the body of the valve can lead to some galvanic corrosion. So if you
Hmm.
remove that wire and replace it with like a high strength EPTFE, which this packing does exist in the market, you can completely reduce or eliminate the potential for the galvanic corrosion that I described before. And as we all know, EPTFE or regular PTFE is very, very corrosion resistant. And so you can use it in harsh chemicals without having to worry about attack to the material.
Right. From a cost perspective, is that something that might keep some people from employing it in their operations, though?
Actually, it is priced at the same level as all or most of the other API 622 certified low
Hmm.
leak technology packings out there. So it's just simply um, using better technology.
Hmm. Yeah, you mentioned API 622. Are there any other standards that engineers should be aware of, or be up to speed on when they're doing valve installation and maintenance?
So for valve installation and maintenance, there are a myriad of different specifications, and I won't try and list them all, but API 600 is one of them. It all depends on what type of valve you're dealing with. But
Hmm.
with regards to packing, API 622 is a really good packing. Another way, if you're trying to test the packing, ISO 15848 is another testing standard that's used more internationally, and sometimes more for control valves, but the results can be applied for static, or excuse me, for um, gate valves and quarter turn ball valves as well.
Okay. Yeah, and along with some of these codes and standards, have you seen any technological advances that have come along in the last few years? I know we've kind of alluded to some of these, but have there been any other real developments in the last few years that you've noticed that have really helped improve the quality of these valves and joints?
So API 622 didn't come out that long ago. So I will say that there was a step change in technology with respect to packing when API 622 came out. So simply using a certified low leak technology is definitely a step in the right direction of implementing new technology that will help with the long-term reliability of your packed joint. But additionally, um, one of the issues with packing is it's really hard to tell good packing from bad packing with the naked eye.
Hmm.
So there's technology that allows you to identify the material. And so those are called identification tags or forensic tags, where you can
Hmm.
actually look at the packing itself and be able to tell if it's a certified low leak technology packing or not. So you can use this as a pre-installation activity, ensuring that the right packing has gone into your valve. You can also use it during an investigation if you're pulling the valve out and you want to make sure that you replace it with the same type of packing. Oftentimes, after being installed for 5 years, you no longer know what packing was installed there, but it worked, right? So what do we put back in there? So you can identify the material that way. And then also, if there were to be some sort of process safety incident, it's a way of proving that you are using certified low leak technology, which is considered best practice.
With some of these new standards coming into place, what do you hope will be kind of like the next evolution with API 622 and some of these standards? Like, what do you hope the next step will be in, improving the quality of these products and improving process safety?
Yeah, so it's a great question. Um, back in the old days when packing leaked, most of the time it was described by some sort of human sense, right? Like how many drips
Hmm.
per minute that were seen, or how bad did it smell, or how loud was the leak, these sorts of things. We're now to the point of measuring things in parts per million, right? So
Hmm.
the test that I described, API 622, is 1,510 mechanical cycles. And there are packings out there that can withstand that test and not leak above 2 parts per million. So they are very, very good packings from that sense. But if we're talking about trying to implement, something new that could help the industry with respect to valve packing, standard joints, like pipe flange joints, heat exchanger joints, those sorts of flanges, really the industry has standardized on an analysis method to be able to determine what is the right type of gasket to use, and then also how should it best be assembled in order to achieve a reliable seal. And some valve manufacturers have implemented this into their valve designs, but users are having to deal with old valves that this sort of analysis method wasn't even around. And some valve manufacturers haven't adopted this sort of analysis method in their design of their valves. So reaching out, performing the end users performing it themselves, or reaching out to an SME to have this sort of analysis performed on the valve bonnet connection, I think would
Hmm.
increase reliability of the joint significantly.
Yeah. And, and with respect to certain industries and certain environments, this is more of an urgent need perhaps in some of these industries like oil and gas or chemical, petrochemical, or processing, where, they are used constantly and they are exposed to a lot. So, hopefully, getting the word out in that respect will help them, right?
100%.
Well, thank you very much, Mark. I appreciate you taking the time today to discuss this topic with me. So thank you once again.
The pleasure was all mine, and I thank you.
All right. And if you enjoyed today's video, you can see other installments of the Maintaining Your Plant Floor Edge series on YouTube at PlantEng and on our website, plantengineering.com. We have other installments of this series, as well as other videos from recent trade shows and events where we talk with thought leaders on the latest issues of the day and what they are also facing in the plant engineering and plant manufacturing world. And I'm Chris Favra. I'm the content manager for Plant Engineering, and thank you for watching this installment of Maintaining Your Plant Floor Edge.